Hi everyone. Today we will talk about data science. First, I will show you some important Python libraries that help with data science. Then we will practice together with some exercises. The best way to learn is by doing. What is data science? Data science is about working with data. We collect data, clean it, analyze it, and make decisions. It is used in business, health, finance, and many other areas. Python for data science. Python is one of the best programming languages for data science. It has many libraries that make data analysis easier. Let's look at some important libraries in Python. First, Pandas. Help with data manipulation and analysis. It is useful for working with data in tables called data frames. Second, Matplotlib. Used for data visualization, it helps create graphs and charts to understand data better. The last one is Scikit-learn. Is used for machine learning. It helps with classification, regression, and clustering. Now that we know about these libraries, let's write some code together. I will show you some examples and you can follow along. The best way to learn is through practice. So let's get started. Let's start with real data. Here we have a dataset of housing prices from 2050 to 2021. On the left we have the raw data in a table, and on the right we have a scatter plot showing these values visually. Each row in the table represents a year and the corresponding housing price. The scatter plot allows us to see trends in how prices change over time. But how we can quantify this relationship, that's where linear regression comes in. Now that we visualized the data, let's introduce a powerful mathematical tool, linear regression. We have this formula y equal mx plus b, where y equal housing price dependent variable, x the year independent variable, m corresponds the slope, rate of price increase per year. I can introduce some video about this. B is the y-intercept theoretical price when year equals 0. Linear regression helps us fit a line that best represents our data points. Let's apply this formula to our dataset. By using linear regression, we derived the following equation for our dataset. The slope m equal 90,000 means that housing prices increase by 90,000 every year. The intercept is a theoretical value, helping define the equation mathematically. With this equation, we can predict future housing prices based on past trends. Now, how do we measure how well our regression model fits data? That's where R-squared come in. The R-squared formula is 1 minus SSR, sum of squared residuals, the total error in prediction, and SST, total sum of squares, the total variation in the data. R-squares tell us how much of the variation in housing prices is explained by our regression model. Let's break it down further. To fully understand R-square, we need to look at these two components. SSR, sum of squared residuals, measures how far actual housing prices deviate from predicted values. SST, total sum of squares, measure how far actual prices deviate from the mean prices. A small SSR means better prediction, while a larger SST means more variation in prices. For our dataset, we calculated an R-square value of 0.9, but what does this mean? An R-square of 1 means the model perfectly fits data. An R-square of 0 means the model doesn't explain any variation. Since our R-square is 0.9, it tells us that 90% of the variation in housing prices is explained by the year. This means our model is highly reliable for predicting housing prices. Now let's move from theory to practice by implementing linear regression in Python using Jupyter Notebook. Step 1. Importing necessary libraries. We start by importing the required Python libraries, Pandas to handle and manipulate data, Matplotlib for data visualization, and Scikit-learn for implementing the linear regression model. Step 2. Loading the dataset. We use Pandas to read our dataset from a CSV file. Once loaded, we display the dataset to ensure the dataset has been imported correctly. Step 3. Data cleaning and preprocessing. Before performing any analysis, it's crucial to clean our data. Here's what we did. Converted housing price values by removing unnecessary characters like commas and ensuring they are in numeric format. This step is necessary because sometimes CSV files store numbers as strings, which prevents mathematical operations. Once the data is cleaned, we are ready to visualize it. Step 4. Visualizing the data with scatterplot. Now let's visualize our data using a scatterplot. The x-axis represents the year, the y-axis represents housing price. Each point on the graph represents the housing price for a specific year. These plots help us see the upward trend in housing prices, which indicates that we can apply a linear regression model to fit a trend line. Step 5. Creating the linear regression model. Now we apply linear regression to our dataset using Scikit-learn. First step is to fit the model using the year as the independent variable and housing price as the dependent variable. Second step is to extract the slope and intercept of the regression equation. The slope m represents the rate of change of housing prices and the intercept b represents the theoretical price when year equals 0. And step 3, print the final regression equation to understand the relationship between year and housing price. Now let's visualize this regression line on our scatterplot. Step 6. Graphing the regression model. Now that we have our equation, let's plot the regression line on top of our scatterplot. The blue points represent the original data points. The red line represents the best fit regression line that predicts housing prices based on year. At this stage, we see that our regression line follows the general trend, but the accuracy depends on how well the data fits the model. Step 7. Splitting the dataset. To properly evaluate our model, we split our dataset into training and testing sets, using train test split from Scikit-learn. Training set 80% used to train the model. Testing set 20% of our dataset used to evaluate the model's performance. By splitting the data, we can measure how well the model generalizes to new data. After splitting our dataset, the training data is used to build the model. The dataset is kept aside for final validation. Here we print both xtrain and xtest years and ytrain and ytest housing prices to confirm the split was done correctly. Step 8. Training the model on training data. Now we train the model by fitting it on the training data. Once trained, we use the model to make prediction on the test set and evaluate its accuracy. Step 9. Checking model accuracy. After training, we use the R-square score to evaluate how well our model performs on the test set. An R-square score closer to 1 means our model makes accurate predictions. An R-square score closer to 0 means the model does not explain much variance in the data. Why our prediction is not perfect? Our R-square score is 0.55, which is not very high. This is mainly because we have a small dataset, meaning our model doesn't have enough data points to learn a strong trend. In real-world application, more data would help improve accuracy. Step 10. Comparing predictions. Finally, we compare the model's predicted house prices with the actual values from our dataset. The table displays the actual housing prices versus the model's predicted prices. We see that the predictions are not very precise, confirming that our small dataset limits the model's accuracy. However, this is just a demonstration, and in real-world scenarios, models are trained on thousands or millions of data points. Now you might be wondering, why go through all this coding when we could do linear regression in Excel in just 2 minutes? We have several advantages of using Python over Excel. The first one is about scalability. Python can handle millions of rows of data, while Excel slows down with large datasets. We have the point of advanced analysis. Python allows us to add machine learning, AI, and data processing techniques which are not possible in Excel. We have the customization. Python gives us full control over the analysis, where Excel functions have limitation, and we have many advantage of using Python. But when should you use Excel instead? Excel is great for quick analysis or on small datasets. If you need simple graphs and calculation, Excel works well. For complex data science and machine learning, Python is better choice. Conclusion. In this tutorial, we saw how Python and Jupyter Notebooks allow us to load and clean data, apply linear regression, evaluate model performance, and automate and scale data analysis. Python is the future of data science, allowing us to work efficiently with big data and AI-driven insights. Let's continue exploring more data science techniques in the next session.